Beyond numbers, understanding the distance formula in geometry. Imagine trying to find the shortest path between 2 points on a map. How do you do that? That's where the distance formula comes into play. It's a simple yet powerful tool that helps us measure the exact length between 2 points on a coordinate plane. This formula bridges the worlds of algebra and geometry, making it easier to understand how shapes and spaces relate to each other. The core idea behind the distance formula is to find the straight line distance between 2 points, which are written as x1, y1 and x2, y2. The formula looks like this. D equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. This might look complicated, but it's actually based on a very familiar idea called the Pythagorean theorem. The theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. In this case, the difference between the x-coordinates and the y-coordinates of the points from the 2 legs of a right triangle. The distance between the points is the hypotenuse. To find this hypotenuse, you square the differences in x and y, add those squares together, and then take the square root of that sum. This process turns an abstract idea of distance into a concrete calculation that you can do on a coordinate plane. Using the distance formula is essential in many parts of geometry. It helps you find the length of line segments, which is key for understanding shapes like triangles, polygons, and circles. It also helps in figuring out the shortest path between 2 points, which is useful in navigation and design. When solving problems involving shapes on a coordinate plane, you can verify if a triangle is right-angled by checking the lengths of its sides with this formula. You can even extend this idea into 3 dimensions by including a third coordinate, called z, which allows you to measure distances in space. This makes the distance formula useful in fields like engineering, physics, and computer graphics, where understanding spatial relationships is important. By breaking down the distance formula, you see how algebra and geometry work together. It makes shapes, angles, and spaces easier to measure and analyze. This simple formula helps us understand the world around us in a clear and precise way, connecting the dots between numbers and the spaces they describe.